My talk is going to be about collective intelligence and creative AI, more specifically, how collective intelligence is a framework for augmenting creative human expression. So this talk or the contents of it came about from discussions between myself and my collaborator, Judy Fan, who is a professor at UCSD and now Stanford. She's working in the intersection of psychology and also machine learning. And as we all know, last year and continuing to this year is we see a huge explosion in generative AI. When I started working professionally on machine learning in 2016, not 2016, 2017, I was dabbling in generative AI, making GANs and sketches, doodles, but it took 6 and 7 years, and this is really blowing up, mainly due to text to image models. And we were kind of trying to figure out why now, like last year, when DALL-E 2 came out, and then Mini DALL-E, and then Stable Diffusion, we've seen the public even use these models. Researchers are all about ChatGPT and Stable Diffusion models and Imagen, Party, DALL-E. And we're trying to make sense of it, not just from the research community, but the public at large, to understand the dynamics behind what makes this particular moments in generative AI so, provocative, or so have this level of impact. And in this talk, I want to summarize my experiences with the research community and also with these text to image models, and present some ideas that Judy and I came with to try to explain this phenomenon. So this is still kind of work in progress, explaining this kind of phenomenon. And maybe after the talk, we can have a discussion about maybe your experiences as well as to why we think this wave of explosion may be explained. So let's dive into the talk. Collective intelligence is something that I've always been fascinated about. As many of you know, I started studying collective intelligence from the perspective of artificial intelligence, looking at these works. Maybe some of you are involved in these works as well, of simulating large amount of agents, where you see some emergence of single agents or single organism behavior. And as I mentioned earlier, Jimmy Ba was ahead of the game as well. He did some work closely related to collective intelligence and reinforcement learning, where they replace every single joints of one agent by a tiny agents, and you have this line of work that simulated a collection of agents into that became one agent. And these agents, due to these shared modular policies, have very nice properties of generalization and robustness. So that's kind of actually what drove me to study more about collective intelligence in AI, ML, and RL setting. But collective intelligence goes beyond artificial intelligence. It defines who we are as a society. It's actually, I would argue, collective intelligence. It's like society is what makes us smart. If each of us grew up in an island by ourselves, we probably will not survive long unless we're living in a collective and defending each other and sharing ideas and teaching each other about our concepts. So that's how I think human intelligence is made up of. But even in nature, we see great examples of collective intelligence, like ant colonies, so on. One of the examples I like is comparing something like the bridge, an example of non-collective intelligence with a naturally formed bridge from ants. I like this quote from Pickering. He once said, "Bridges and buildings are all designed to be indifferent to their environment, to withstand fluctuations, not to adapt to them. The best bridge is one that just stands there, whatever the weather." But in contrast, something like a bridge built with ants, by ants, or something designed by a collective of organisms, agents, or even humans have this sort of a lifelike property that can be fluid and dynamic and always coming out with new things to adapt to whatever environment. So if we actually look at an example of collective intelligence for image generation, so what if we decide to step away and not use GANs or stable diffusion models? What if we try to use like a collective intelligence, a human collective intelligence to generate images? It's kind of like this experiment on Reddit. Every year they have a Reddit art place experiment where they generate images. And I would think this is something like a collective intelligence applied to image generation. So in this experiment, you have a 1,000 by 1,000 pixel canvas. So there's 1,000,000 points. Each Reddit user can only draw 1 pixel every 5 minutes. So that's the limitation. And this contest lasts for a week. There's no goals. They can just do whatever they want. And what they found is every time they launched this experiment, the population of Reddit users tend to coordinate on strategy and on their discussion forums on Reddit to defend the designs. They would attack other designs and form alliances. So I think you see many interesting patterns and destruction and reconstruction happen. And I think something like this, image generation as a collection, it has its own interesting properties to robustness as well, compared to traditional single person image generation. So if we look at the idea of collective intelligence applied to content creation in an AI or even neural network contents, we don't have to look that closely at the recent past. Even maybe like back in the early 2000s, in 2007, there was an experiment from Ken Stanley's group called the Pig Breeder experiments. And in this experiment, the idea was to have a collection of users individually evolve neural networks. By evolving, it means like evolving the structure of neural networks, the architecture. And every neural network would correspond to a pattern. And what they found was, by having thousands of people participate in this experiment and building on top of each other's designs, you get lots of incredibly novel and interesting designs like the one on the left. And this was back in 2007. These are created by very simple networks. And I think this is an early idea of collective intelligence applied to neural networks, human collective intelligence and artificial neural networks. So one of my first experiments when I dabbled in AI is to re-implement the networks in Pig Breeder. So in this example, the network on the right is like this very simple evolved network structure with evolved weights as well. And you feed in the coordinates at the bottom, and you get the output at the top, like the RGB. And if you do that on every single coordinate in the pixel space, you get this rocket ship. So these are things that can generate very high resolution images. It's kind of like an early version of NeRF back then. So I used this algorithm that I created and ended up creating some pretty wacky, cool arts a few years later, which were pretty high resolution. This was before high resolution GANs or computer image generation models. 4,000 by 4,000 images, which is still challenging today. And I think all three designs came from this similar basic network, but evolve in different ways. And I eventually incorporated some of these ideas from CPPNs into deep learning. So rather than classifying MNIST or making VAEs of tiny MNIST back in 2016, I combined these CPPNs and make like a generative model of high resolution MNIST. So you can have MNIST digits that are like 10,000 by 10,000 resolution and so on in theory, and they can kind of move around. So that's kind of like a I thought it was interesting to take an idea inspired by this collective experiments on CPPNs and combine that with backprop and deep learning. And another example of this collective knowledge distilled into a data set is this experiment from Google that I helped out on called the Quick Draw data set. And the Quick Draw data set is a collection of data collected from this game created by Jonas Yejin at Google Creative Lab. So the users have 20 seconds to draw something that they were told to be drawn. And users were very obedient. If you tell them to draw a bear, you know what? They draw a bear most of the time anyway. And through this experiment, somehow this became viral and people loved to play with this back in 2017 and 16. And we collected like hundreds of millions of doodles. I think then Google cleaned this up, removed all the dicks and Nazi signs and whatnot. And they released an open source data set of 50 million drawings. And it's downloadable. So this is another example. I would say it's like an idea where we can collect this collective knowledge from the masses distilled into public data sets that people can use to train machine learning models on, which I did. So I took that data set and trained generative models to doodle. This model called SketchRNN, it's kind of like an autocomplete for sketches. You start drawing something and it can try to finish it. They can draw like gardens, faces, owls, mosquitoes, and fire trucks. If back then I made a web browser demo, so if you draw the cloud, it can finish the rain in different patterns. I kind of like this interactive way to play around with these models. So it kind of resonates with the modern version of Stable Diffusion or these models that are available on the web, and you can see results really fast. So artists can iterate on the concepts without waiting half an hour for the results. So you can wait maybe 10 seconds or 5 seconds for the results, right? And back then, what I did was to open source the model. So I think this is a theme that I'm going to talk about later as well, like releasing all the weights to the public, as an open source code, and making it very easy for anyone, even outside the research community, to use. And we've seen people just take the model and do weird and fun things, like hooking it up to some plotter and generating lots of cats, or hooking it up with a little robot and drawing the birds. Some people back then tried to hook it up to a buildings, and they in Paris, and they generated some doodles, and there's and handwriting and so on. So that was kind of fun. And eventually this work, SketchRNN and Quick Draw, was fused with one of my collaborators who was a PhD student at Berkeley, called Sketchform. And what Forrest Huang did at Berkeley was he combined all of the Quick Draw data with various SketchRNN models or multimodal SketchRNN models trained to generate all of the SketchRNN or the Quick Draw conditions. And he used a very simple form of word embeddings. Like that took a sentence and moved it into embedding space. And the SketchRNN would draw something conditioned on that embedding space. So this was something that was initially released as a preprint in 2018 and early 2019. But it was kind of amusing because now everyone thinks text to image is just a given. People can just do text and you can have an image. But just that time, just like 4 years ago, that you can type a text description like a boat under a bridge, and the machine would doodle a boat under a bridge in some limited capacity, seem very magical compared to now. And I think this was one of the early works that demonstrated the concept of text to image via text to doodle using the Quick Draw data set. So I advised Forrest on this work, and then I kind of like took like a detour in research. I worked a bit on generative models and generative videos in the context of trying to do action conditioned video generation of game environments. This is the line of the World Models work with our buddy Schmidhuber, who I collaborated with, and I think this work was also extended by other researchers like Danny Jar Hafner on a line of work on latent dynamics and latent diffusion. No, sorry. The Dreamer and Dreamer V2, V3 line of work. I really enjoyed this research topic. And eventually I dabbled onto RL and collective intelligence. But somehow at the beginning of last year, even like around the time when DALL-E 2 took off, I started playing around with text to image models, and I became really addicted at playing with text to image models. I tried to understand them, how they work. I work with Google's internal Imagen team, who also worked on their text to image models, which they actually had working months before DALL-E 2 with this quality. Which was kind of amazing. And when I started using this model, I thought something clicked. This is the future. It's going to change everything. I was like spending all of my time at Google, getting paid a Google salary to play with text to image models, making pictures of like the bears running triathlons or paintings of cats on stamps. I think we can all agree that text-to-image models are a major advancement in 2022. I think they're applied in many ways. There's the whole art community, like there's artists or digital artists using these models to make paintings of various styles, like Oriental painting of like a dragon on a laptop and some cyberpunk style. There's also the concept art or people making weird things, like a DSLR photograph of a strawberry frog, and you get something like this dreamed up. So I think these models apply to all sorts of use cases by several different communities. So my own experience of text to image models, like it seems like a very long time ago, but it's actually less than a year ago when this stuff was out. And now everyone has access to it because of Midjourney, Stable Diffusion, and all of these services. But it seems a long time ago, but there was a time just last year when only a very small number of people had access to these models, and people felt really privileged or special for having access to them. It was really weird. I think I was the very first user or one of the very first testers of DALL-E 2, because I knew people at OpenAI and they sent the invites. And at the same time, I was very lucky to have access to both of Google's Imagen and Party models internally, which they still haven't released. And there were very limited users for DALL-E 2 and Imagen back then. I'll discuss more about the power of having an open source model that allows a critical mass of users to try these text to image models later. But like back then, like just a year ago, it was like available. There was all hype, but it was available only to a very selected small group of users, and it felt really weird. I started playing with these models by creating like most people would, like artistic images with known artistic style, like digital art, cyberpunk, trending on ArtStation and whatever. There's like the Banksy graffiti with Totoro that looks like a Banksy. And then afterwards I tried to create some images with some degree of realism, but also with some sort of conceptual idea, like the humanoid falling in love with the human, and also the realistic bears having ramen at night in Shinjuku. Also, I tried to test to some of these images with some degree of emotion, because these are trained on text, and I think the text embeds a lot of like human emotions and human desires inside the text with these text to image models. So you can create like romantic images of things like robots and happy cats and so on. And I also like to study their ability to learn abstractions. That was actually one of my main motivations in the sketch RNN or quick draw line of work, seeing how machines or neural nets can represent simple drawings. And these models also have the capability to generate like Picasso minimum line art of New York City. And it can create like a Lego image of people like Jay-Z or Jeff Bezos, Rihanna. So these kind of convinced me that these models learn more than just memorizing images, because I don't think maybe the Jeff Bezos exists, but I don't think like Rihanna's Lego exists and it's able to come up with that. So it knows a thing or two about what she conceptually looks like. And because I'm on Twitter quite a bit, I can kind of see the engagement level from some of the posts. I find that the images, not with the highest quality, but but uh, but with some cultural factors, receive the highest engagement. So things that were a bit more meme, rather than it's beautiful looking, like a photograph of a bear stock market in the 1930s, and the model mistaken the bear market with a bear, and that made people think it's funny. Or maybe like a Bitcoin in Edo period, and people thought that was funny back then. And these models, I try to use them for things like novel combinations of distant concepts, because I want to test. It's fun to do that, but also we know that these are definitely not examples, or some of them are not examples on training, right? Like I don't think there's a Darth Vader on the cover of Vogue magazine that often, or maybe Darth Vader at a tech conference, trying to pitch deals to VCs. You all have to do that eventually after you graduate, but and go to a startup. But it was kind of fun to use these models to combine different concepts. Another example that was kind of fun in the community is to reverse engineer DALL-E. As we all know, DALL-E tried to enforce lots of, well, not lots, but some censorship into the prompts. So if you type in some words, it doesn't actually allow you to do that. It would like say you're violating the terms of service. So you can type in like Elmo holding up a sign that says like "fuck you," and it can try to generate the text sometimes. There was another example of, because the data sets, one of the challenges is like the data sets that DALL-E was trained on, and many of these models are data on the internet that reflects human biases, and also there's lots of bias issues in the data set. So OpenAI introduced some fixes to data set bias, to debias the data set, but they wouldn't really tell people how they did it. People just found out that like when they paid for a bunch of prompts, and like maybe 2 or 3 of the prompts are like should be debiased or something like that compared to the original images. And this is an example I would say is like the ingenuity of human intelligence. Like people figured out that by tagging certain words under the prompt, like simply typing in the prompt like a person holding a sign that says, and without anything more, and then the DALL-E 2 generates like a image of a person holding a sign that says black or female. So then people reverse engineer DALL-E to discover, hey, this is how they debiased it by changing our prompts, by putting prompts on there. I think that's fine, because it is actually kind of a novel approach. They use a prompt engineering approach to debias it, but it would have been nice if they were more transparent about how they approach the debiasing technique, so like the community can get involved and do some more analysis to try to improve it. But it was interesting that people quickly figured out how they did it, like literally within a day. It goes to show how powerful the human user community is when they're using a new machine learning model. So this was around June 2022, like middle of last year. And I was thinking, what's next? You have all these fantastic technologies like text to image models from Google and OpenAI. So is the future of text to image models, or these large models, dominated by big companies like OpenAI and Google, now Microsoft, who can train bigger models on bigger data sets? Like that, it certainly seems so. Like if we study the results from the party paper from Google, they have this plot that shows that as we scale up the model, like from 350 million parameters to 20 billion parameters, the model suddenly gets much better structure, and you get like rubbish text to clear text. So it certainly seems that it was a race of larger computes, bigger models, and larger scale, right? Like the picture lesson goes in the shape, and maybe that they're gonna dominate text to image models. But there was a plot twist back in, uh, if we go back to 2 years ago, back in 2021, there was a group of people who was invited by Hugging Face into a hackathon. I think this was led by Boris Dema, and there was an open source effort to reproduce the original DALI model, which they called DALI Mini. And this was done on like some donated compute, I think on a TPU or something. And they were able to train like a decent, like an okay-ish DALI model called DALI Mini with a few 100 million parameters, which also did text to image. It was not as good as DALI 2, but they released it to the open source world. So everyone can use it on their own machines, and there was a server that serves it with not so much censorship, I think, and people just used it. And for a time, it was really funny. It was like every one of us knew DALI 2 because we're in the ML community, but the world at large didn't know last summer. So last summer it was DALI Mini, not DALI 2, which ultimately became a viral meme on the internet. Like so it was kind of funny that like they were saying things like the internet has decided that lo-fi pixelated sloppy memes tend to be funnier, and and it seems to be DALI 2 because maybe of the low quality and the data set decision, or maybe there's less weirdness going to curate the data set. It was just whatever they script on the internet. It turned out that it created things like deep fried memes better than DALI 2. So you can type in something like Eminem as an M&M, and you get like Eminem as an NMN. So that was kind of funny back then. Let's see. So this became such a phenomenon. Like I think DALI Mini made text to images. It was the first model that was well known to the general public about text to images. Not Midjourney, not DALI 2, although Midjourney caught up later on and Stable Diffusion caught up later on. The New Yorker had a tweet where they mimicked DALI Mini's iconic 3x3 grid. And they show that maybe that the future of art is based on text to images, or the future of illustration. And because Mini DALI didn't do things like censor political figures, people can generate things like artistic figures of Biden and Trump using DALI. And some people even made a meme for DALI Mini. There's all image AI models are very powerful, so we'll roll out DALI 2 to a selective group of artists or people at first. And then while people in the open source community are generating minions at cross burning, but the censor model, like we monitor for violence and know people violence and ensure safe and whatever. And they're generating Jar Jar Binks at Nuremberg trials. And there's like weird art like gender reveal 9/11. It's kind of crazy. Like so I became a follower of DALI 2 because like there was such a big community using it, creating viral memes just using a simple AI tools. And I think DALI Mini offers a hint of creativities of the masses being unleashed, because it's so easy to create these, right? This casual creativity revolution, I think, is real and it's not going away. Like people can just type in a prompt like Death Star explosion gender reveal because they saw another gender reveal prompt, and you get something like that. If a funeral at Walmart's, and you get a funeral at Walmart's. Neurosurgeons placing ramen inside a man's head as a joke, and this happens. I don't know how you think of these memes, but this is hilarious. There's like Jesus at a bar after a long day of miracles. Mickey Mouse under electron microscope, and Boris Johnson made out of Play-Doh. It's pretty funny. I find that there's there's a method to prompting these models, because these models were trained on data collected scraped from the internet. So whatever concepts that happen to have a large data distribution, like beers and Jesus, or electron microscopes, because maybe there's lots of images out there, and Mickey Mouse, or Boris Johnson, and random Play-Doh, you can combine those and get them to work. So as long as the individual concepts are common, then you can get some interesting generations from these models. And I think DALL-E Mini showed me that it's not just about scaling the model size or computes. It's about scaling the number of human users, like actual number of users of your model. And we see things like online. What happened is, like, everyone plays with these models a lot, and then iterates and figures something interesting. And once they have something interesting, they would post it on a forum like a Reddit. And if they were interesting to other people, those would get upvoted. So it's kind of like a two-step evolution. You have to choose. You have your own selection, cherry picking yourself, and you have the group cherry picking at the societal level. So the top images voted are survive some sort of a optimization process. And I think the final images is a combination of the prompt and image selection. So it's not like just the prompt or just the image, but it's a synthesis. It's a complex feedback loop between prompt and images. And at the top, you get, like, the Marxist monopoly. Okay. Let me go to the next slide. So to expand on this thoughts, these models, what people usually they tend to discover is what works on one model doesn't work on other models. So if you type in something really funny, like YouTuber going to funeral unboxing on DALL-E Mini, and you type the same prompt in DALL-E 2, it's not funny at all. It just looks like a bunch of stock images. It's not to blame DALL-E 2, but maybe because, like, the final prompt image pair was selected so that it works really well on one model through iterative cycles, that we can't expect the same effect if we reuse the prompt in another model. But that can actually be a research topic. I think some people are working on ways to transport prompts from one to the other. But I think I was commenting on this one when someone typed in, like, a lo-fi nuclear war to relax and study to. It was like just this prompt and this model that worked really well. And I noted that, like, the most interesting and viral images that you see produced by text to image models are not merely the results of the deep learning models themselves, but rather the result of this complex feedback loop between a neural net from a human, like our own brain, interacting with an artificial neural net. Let me check the timing. So another reason why DALL-E is a hit, because it can portray cultural items that reflect current issues. Last year, the U.S. had this horrific gun shootings at the schools, and people were angry. But people also used DALL-E Mini to let off steam by typing in memes like "Fisher Price, my first hand grenade," to make fun of the gun laws or the weapons laws in the U.S. And when there was the Supreme Court decisions on abortions, people used the models to generate Supreme Court dressed as clowns, and they shared that, and people like that to pull off some steam. So. Well, one of the things when I was discussing this with my collaborator, Judy Fan, how this particular text-to-image creative process can augment human creative expression. So the example we have in this process is, like, if we go look at the top left, if we look at how people use this, it's like you can look at the painting of a lady, like a Mona Lisa. They can try to regenerate that. It's a well-known but boring painting. But then you have an individual exploration. They can try to generate the same thing in different styles, try to make Mona Lisa more funky, and share that with the community with different variations. And you get this feedback dynamics from the social network as to whether people like the Mona Lisa with the astronaut, or the Mona Lisa is actually a dinosaur. And the user gets some of that feedback from social media, because people are just addicted or to share stuff, as we know, and people just like to share. Now, if they have a new text to image tool, they want to share that and see what ticks. So this is sort of like the one iteration of how this sort of process might augment human creative expression. Let's see, going back to the next stage. And we think there's really three things going on, three phenomenon going on for text-to-image models to augment human creativity at scale. One is they enhance a person's ability to explore a wide space of possibilities, individual exploration. They heightens a person's drive to share what they have created with other people, like through social media. And with the feedback dynamics, it unlocks this feedback dynamics that accelerate the so-called diffusion of innovations across large communities of the social network. So to build on this, we notice that innovations that are learned are passed on to other users and are built upon. So when some people discovered that DALL-E Mini can generate sketches of courtroom sketches, which are pretty funny, like Godzilla testifying at a courtroom sketch. They reuse that concept to make like a bottle of a ranch dressing testifying in court, or alien appearing in court for damages caused by abductions. So people build onto concepts that work, and even things like gender reveal, courtroom sketches, and Terminator and Darth Vader and so on. People found out that these models were good at creating PlayStation 2 memes. So you can make like a 10 square for PlayStation 2, but maybe due to the bias, a few tanks showed up in the internet. There's also American Psycho on PlayStation 2. And there in the literature, back in there in the psychology domain, there's a lot of research that backs this up. In particular, the cultural transmission and the diffusion of innovations, how people like to build things that were discovered in the community. So it suggests to this, but now these text-to-image models are enabling a broader version of this with the rise of social media as well. So in general, I think like future models or future types of technologies like text-to-image, if they follow this sort of pattern, we can expect them to see similar types of dynamics, where basically you enable individual exploration. So you have one user that can iterate on the tool or the model, and you enable a drive to share. So the users wants to share their creations quickly to their community or friends, and then you have a network dynamics that will give the user feedback. However, I think like when we think about the open source models, not just DALL-E 2, but like DALL-E Mini or Stable Diffusion, where developers can get involved and play around with the model, you actually get a much broader, another level of dynamics. So rather than having the individual artists or the user play around these models, you can have individual hackers, researchers, or developers all trying to change these models or improve them, and feed these improved models back into the world to get feedback. And this is another level of this diffusion of technology, not just diffusing a prompt or some meme images, but like getting newer versions or improvements of the models out. And I think this is very powerful. And this is the rest of the talk. I'm going to use Stable Diffusion as an example. I want to check the time though. I got 10 minutes. And there's three areas. There's creative applications, model tinkerers, and research. So I'm going to focus on Stable Diffusion. I think Stable Diffusion is when we went from AI memes from DALL-E Mini into AI arts. And this is the Stable Diffusion community is really weird. Like there's all sorts of people with all sorts of different interests in this community. Some people like to make realistic art. Some people like to make like memes, and some people like to use this for their hobbies, like using Dream Booth to make wedding images. In particular, the first area I want to talk about is creative developers using open source models like Stable Diffusion. And once we have a model open source to the public, we see instantly all sorts of applications, plugins from Photoshop, Figma, Blender, thousands of other applications spring up. This is something that no individual companies can do. There's just too many different variations. Like within days after Stable Diffusion, someone created a plugin for Blender where they can sketch some preliminary drawing, and you type in a prompt, and Stable Diffusion would like use that prompt and change the doodle drawing into a shoe, right? Within days as well. Some people made a Blender plugin. Oh, sorry, this is a bit loud. Where they can turn a simple scene into using the Stable Diffusion to render it, into something more realistic. And we also talk about community-driven approaches for improving these models, since it's open source. Like the community at large just hacked around with these models and figured out many ways to improve them. Like the idea of negative prompts was from the community. The way that you can combine models using blended models or cascade them together, fine-tuning them. Even recently, people were like Apple was making M1 optimizations to Stable Diffusion, and there were efficient attention layers that were written in libraries or fused models tailored for Stable Diffusion. So it was pretty cool when you have a model released as an open source project to the wild, and just you let the community improve upon that model. So here's an example of a negative prompt. By using negative prompts, you can make better looking burgers. You can cascade images from DALL-E Mini to Stable Diffusion to make better looking gaming toilets that look like GPUs. There's a whole community of fine-tuning Stable Diffusion to make them produce better images in certain domains. So I think customizing or fine-tuning models really quickly really shows is probably worth the equivalent of maybe 3 orders of magnitude of additional scale, because you will need that much more data to cover all of these different individual domains that users need to generate images on. There's also things like model distillation, where you can train these models on large data sets to mimic other models like Midjourney. And I want to finally close with talking about maybe to this community how open source models act as a foundation of research. We've seen something like Stable Diffusion become more like an open standard for academic community to communicate research, because since the model is out there, for better or worse, people can use the model, reproduce research, and ensure that the ideas are communicated on a standard platform rather than through an API of someone else's proprietary model. We've seen examples like Dream Booth, and I'm going to talk about more that were built on Stable Diffusion. Like one of the interesting things is an idea like Dream Booth that came up from an intern, Nathaniel at Google Research, was originally done on the Imagen model, like their closed model, but they couldn't release it. So after their paper got out, people adapted that Dream Booth model to Stable Diffusion, and it became such a hit that realistically, when you talk to people about Dream Booth, they automatically associate Dream Booth with Stable Diffusion rather than Imagen, which is really weird because it was done at Google initially with the Imagen model. And there's other newer models using Instruct models to fine-tune Stable Diffusion. Instruct Pix2Pix allows users to use natural language, combining innovations from NLP space into Stable Diffusion. So you can things like type in a prompt with instructions, and it'll change your Stable Diffusion latent space so that it can generate the intended thing from the user. People are working on attention or interpretability using Stable Diffusion as a foundation. There's also research into diffusion research itself. There's papers recently on things like distilled diffusion models, on distillation of guided diffusion models to make them more efficient. So I think stable diffusion is becoming kind of like the VGG or AlexNet model for academic and industry research labs for communicating ideas in the community. Even weird enough, there are people in the medical AI space using stable diffusion for things like creating extra data for X-ray and radiology report data sets which are controllable through text prompts. And they've shown that these models can improve the accuracy, for these medical applications. I would still take this with a grain of salt. It's only a preprint, but it's been published by a lab at Stanford, and maybe they want to present it at a journal. Who knows? So maybe to end this, it's still, I don't think it really works, because when you look at a generated X-ray, we still have problems generating hands. So maybe someday the model will finally do the hands rights. And I will end my talk there. Yeah. Hey, thanks everyone.
Wow, thanks, David, for such a wonderful and fascinating, and also incredibly intimate personal journey of discovering hints of intelligence and sparks of creativity in machines. Yeah, you could
thanks.
probably they have the fantastic prompts and where to find them.
Exactly. Yeah, it's all community generated.
Yeah, I guess we'll now start to take questions from the audience. I guess I have a couple questions. Too many, but I'm gonna restrain myself. One is so I guess I really love the lo-fi nuclear explosion photo. It actually caught my attention quite a lot on Twitter too. And because in the slide earlier slide, you actually mentioned that it's really difficult to steer those models to generate those surprising a particular visual effect you will like, and it probably only worked for one of the models that has been explored a lot by the community. So, and prompt doesn't really transfer, right? So and I noticed when the stable diffusion models go from 1.5 to 2.0 and 2.1, the similar phenomenon happens too, right? When there's some I don't know, some certain artist name when being mentioned, it just generates a lot better. And is that, yeah, how do you think about that? And what?
It's very tricky. I think so for that one, no one, for the record, no one tried to remove the artist in the training. What happened was we thought open clip was better than the original OpenAI's clip, because OpenAI's clip was trained on whatever data set that we don't really know, but OpenClip was trained on a Lion data set. And I think once we replaced the old clip with the new clip, it would automatically, people are so used to prompting with clip, not with OpenClip, that you lose it. But the next versions of the model, we're playing around with combining the two clips or even distilling the two clips, so we should get lots of that back. So yeah, we're trying to figure out ways to make prompting easier. I think ideally we want to have a minimum description length of prompt that generates something really interesting. I think that's probably will make the model easier to use.
Yeah, because to me, different models almost speaking their different alien language, right? And then when the next version comes in, you have to really learn this new alien language, and the the previous mind, if you view the communities as miners for those prompts, then they the previous knowledge has been lost. Once you move on
Ideally, another idea we had was to take the best prompt from the previous model, and to use to prompt images and to use those images as a training data as well for the new model. So you kind of using model distillation to ensure that the best stuff from the old model is reproduced from the new model.
Yeah, that's the best knowledge of our society of prompt engineers.
Exactly.
That's the vibe.
One day we don't need prompt engineering. I think once we get once you guys discover AGI, we don't need prompt engineering anymore.
Yes, it's it will be turned all the way down.
I got one more time for one more question. I kind of have to go in 2 minutes, 1 or 2 minutes.
Okay, anyone from the audience? If not, then
Maybe.
maybe I could ask like something more relevant to I guess all the students here, right, at Vector. So how do you think how does grad student get into this sort of creative intelligence and synthesis art realm, and what would be the most useful skill to develop? Because
Yeah, well, I think
you were the first person who kind of like took on like the compositional pattern producing networks and stuff way back, right? The second person was Josh Tenenbaum, I know, took those ideas seriously.
Yeah.
Yeah, so it seems like it requires understanding from very wide range of literatures that usually not in the spotlight.
Yeah, like I don't know. I it's just weird. I just try to read about concepts from other fields, just to grasp, because especially now when it's so competitive when you try to like publish something, right? You might as well try to take some risk and take some nice ideas from another field and introduce them to machine learning, and you can get some novelty prompts for points for doing that. Just combining. I don't think you really have to. People have to do collective intelligence, but I think it's generally a good idea to take something really interesting from an adjacent field and apply them to machine learning. And I think that seems to be a recipe that works time and time again. I see from other colleagues as well, like
Right.
neural ODEs, or like many of your own work is like that as well. When you look at some of the looking at other, like the graph neural networks. So I think, yeah, there's lots of opportunity, especially in this era of competitive publication. You almost have to like steal some ideas from other fields and like, coin them for machine learning.
Yeah. Oh, excellent.
Cool.
Yeah, I hope
Cool. I got a jump, but yeah, thanks so much for inviting me.
yeah. Thanks, David, for the talk.
Okay.
All right. Yeah.
All right. See you
Take
later.
care.
Bye.
Yeah.
Yeah.
You're